We have another idea about functions too. Functions can be added or subtracted, multiplied or divided. So I want to show you, I'm just going to set up a couple little problems to help you have an idea to see what that means. I have two functions, f of x and g of x. This first term is asking, what are the functions f plus g of x? Well, what that is asking then is basically f of x, which is 1 over x plus 2, plus g of x, which is x over x minus 1, or f of x plus g of x. And then I would add those two rational expressions on up. Now remember, right now I would not be able to add those rational expressions until I get common denominators, but that's just a hint for you as you continue to explore that problem. I also want to make note too that I have some domain restrictions. Always want to keep an eye out and look at those. This rational expression is valid for all values of x except for negative 2. And this one's valid for all values of x except for 1. So I do have some domain restrictions to be aware of. F minus g of x is f of g, f of x minus g of x, or 1 plus x plus 2, take away x over x minus 1. And I'm going to put this around parenthesis because I want to make sure I subtract the entire function. The next one is f dot g of x, or f times g of x. And maybe I should write over here, it's going to be f of x times g of x. So let's just multiply those functions. 1 over x plus 2 times x over x minus 1. Multiply that out. And I can multiply that out fairly quickly for you. 1 times x is an x. The denominators, x times x is an x squared. Minus x plus 2x gives me a plus x minus 2. So there's that function, or that new function, f of x times g of x. And lastly, f divided by g of x equals f of x divided by g of x. So I'll just write that down as 1 over x plus 2, f of x, divided by g of x, x over x minus 1. I know I have a complex expression there, or a complex rational expression to solve and reduce. So that's how you set those problems on up. Solving them from here on out, we need to refer back to some of the things that we've learned before.